All right, today is kind of catch-up day. I will let you know that you need to get out a piece or two of paper, and you're going to write down all these notes that's going to be up here on the computer. I will have this video posted online if I go fast and you miss something, but you need to write everything down, and we're going to try to play catch-up. Okay, this is section 1.3, and first we're going to finish up how to do homework number 6. So the first thing that we're going to talk about, and we did a little bit of this the other day, is what do you do when you have a piecewise defined function such as this, and I ask you to graph it. So what I told you to do Friday was to make an XY chart for each part of the function. Now what's important is the domain restriction on these things. Okay, the domain restriction is this little piece right here. So what we did Friday was, if this says x is less than 2, you must start with 2, and then you pick numbers that are less than 2. So you would pick like 1 and 0 and -1, and you would plug those numbers in. So for instance, 2 times 2 plus 4, that would be 4 and 4 is 8. 2 times 1 plus 4, that would be 6. Plug 0 in, you get 4. Plug -1 in, and you get 2. And then over here, since this equation is true when it's greater than or equal to 2, you start out with a 2, and then you pick numbers greater than or equal to 2, like 3 or 4. So 5 times 2 would be 10. 5 times 3 is 15, and then 5 times 4 is 20. Now, the issue here then is, as far as what to do next, is you can't have 2 points at x equals 2 because it wouldn't be a function. So if it's got an equal to right here, that means this is a closed circle. In other words, it is a dot. It is a solid dot. But on this one, since it says x is less than 2, this is an open circle. Now, it's just for 2. So what you would do then, we'll do y equals 5x first. I would have 210. And I'm going to do these by 2's, 2, 4, 6, 8, 10, 12, 14, 16, 18, just to have an idea of what this looks like. So I've got 210, which would be right here, closed circle, then 315, that's about right here, and that's going to be a straight line going that way. But when I go and do 2, 8, that is an open circle. And then you would have 1, 6, 0, 4, -1, +2, and this would look better on graph paper, but that'll be something like that. So that's how you graph a piecewise defined function. All right, let's do one more just to be sure we've got it. All right, let's try one that is like number 45. This is the one we started Friday. So I'm going to do number 46. I think we began this in the notes. It says something like g of x is x plus 5 if x is less than or equal to -3. It's -2 when -3 is less than x less than 1. And then it's 5x minus 4 when x is greater than or equal to 1. So you should already have this in your notes, but what we did is we had 3 XY charts, one for x plus 5, one for -2, and one for 5x minus 4. So we'll start with this one. This function has a domain of x is greater than or equal to 1. So that means you start with 1, and then you pick a couple of numbers bigger than 1. So I'll plug 1 in here. 5 times 1 minus 4, that is 1. I'll plug in 2. 10 minus 4 is 6. 3, 5 times 3, 15 minus 4 is 11. Since this has an equal to, the 1 will be a closed circle. Alright, then I'll go to this equation, which I use when negative 3 is less than x less than 1. Okay, this basically means g of x is y equals negative 2 between negative 3 and positive 1. So you have to include negative 3, that number, and 1, that number. So numbers in between there would be like negative 2, negative 1, and 0. Now this one's confusing sometimes because it says y equals negative 2. It's not negative 2x, it's not x minus 2, y is negative 2. That just means y is negative 2 all the time. Nothing to plug in, just y is negative 2. Now the hard part, less than, less than. That means you have an open circle at the endpoints. At negative 3, since that has less than, you do an open circle. Less than, open circle. Last, we go to the top equation, and its implied domain is x is less than or equal to negative 3. So you start with negative 3 and pick some numbers less than that. So I'd plug in negative 3 and I'd get 2. Plug in negative 4 and get 1. Plug in negative 5, get 0, and then plug in negative 6. Since the domain restriction here has an equal to, that is a closed circle. Alright, so now we get to the fun part, which is sketching this. So what you have first, if you start with this equation here, you've got negative 3, positive 2, closed circle because that has an equal to there. Negative 4, 1, negative 5, 0, and then that goes this way. Alright, now the equation in the middle, which is negative 3, negative 2, that is an open circle. Remember, this was an open circle because of the less thans here. Then negative 2, negative 2, negative 1, negative 2, 0, negative 2. So we're going to connect the dots in between. But then at negative 1, negative 2, it's another open circle, and that's because of the less than there. Then this equation, 1, 1, 2, 6. And you can plot some more points and see it's a straight line going that way. So you have two problems like this, 41 and 45, and you need to try these. All right, then the last of the homework is on something called even functions and odd functions. Here, let me go back just in case you didn't get a chance to finish that. So we've got even functions and odd functions. Now, on homework 6, the way that you determine if something's even and odd is you just look at it. If it's a polynomial function, you can just look at the function and determine if it's even or odd, and then I'll tell you what it means. So we have an odd function and an even function. All right, so there's two things on homework 6 that you have to know. First of all, if it's a polynomial function, if you have a polynomial function and you have all even exponents, which includes 0, that's considered even. And then if you have a polynomial function and you have all odd exponents, that's considered an odd function. All right, so for example, if you had x cubed plus x, Notice this exponent is 3. This exponent's understood to be 1. Since all the exponents are odd, you would consider that an odd function. On this problem, say you had 3x to the 4th plus 12x squared. Since the exponents are both even, that's considered an even function. But let's say you had a function where 2 of the exponents were odd, and then I throw in here an even exponent. Well, they either have to be all even or all odd, so here you would just say neither. Because those 2 are odd exponents, this one right here, though, is an even one. All right, and then you have the oddball case. What do you do if you have, say, a constant number? Like, is that going to affect the problem? Like if I have x squared plus 6 and x cubed plus 6. Well, the 6 has an understood x to the 0 exponent. So that's considered, 2 is considered even, and then we're going to consider the 0 as being even. So this one right here would be an even function. 3 definitely is an odd, but since we're going to consider 0, like 0, 2, 4, 6, 8, 10, 12, that's even. So if you have a combination of even and odd, you just say that function's neither. So it's neither even nor odd on that one. All right, so that's how you do problems number 49 through 52, and then 63 through 68. All right, so then the question is, well, what's the point? Okay, they're even and odd. Who cares? What's the point of it? Well, the point of it is, if you have an even function, it has symmetry with the y-axis. Without even graphing it, you'll know that, and we'll look at one in just a minute. And then if it's an odd function, you automatically know that it has symmetry with the origin. And I'll explain what that means in just a minute. So on homework 6, even functions, symmetry with the y-axis. Odd functions, symmetry with the origin. All right, so if you'll get a calculator out, let's just look at what a couple of these functions would look like. So you may want to get a calculator out, and let's look at an even function and an odd function, and I can tell you what the symmetry, what I mean. All right, so on your calculators, if you'll press home, over, and then we'll do a graph. And let's just do the most common even function there is, which is x squared. Y equals x squared. Well, what you'll notice about y equals x squared is first, it has an even exponent, so that means it is an even function. And then if you had a calculator and could graph it, you can easily see it has symmetry with the y-axis. And there's 2 ways you can tell. First, if you look at the y-axis right here, obviously it splits that graph down the middle. So what does it mean that it splits it down the middle? Well, for instance, this right half of the graph, if you reflected that over the y-axis, would go right there on the left side. Like all of this in the first quadrant would flip over here to the second quadrant. Okay, what else does it mean? Well, the other thing that it means is that if you have a point x comma y on the graph, then you also have a point negative x comma y. Okay, so what does that mean? Well, clearly 2 comma 4 is on your graph. So that means if you reflect that over the y-axis, you know another point, which is negative 2 comma 4. 1, 1 is on the graph. So if you reflect that in the y-axis, you should also know that negative 1, 1 was on the graph. And so on. We could just keep on doing that. So y equals x squared is your most common even function, has an even exponent, symmetry with the y-axis. Now in the homework, they're going to tell you to, once you do this even and odd business, to graph it on your calculator and see, compare your answers to what you think it is. And so that's the only reason. All right, let's do an odd function. So let's do home over enter. And this time let's do x to the third power, and y equals x cubed is the most common odd function. Clearly it has an odd exponent, so it's considered to be an odd function. And it has symmetry with the origin. All right, so what does that mean? Well, what it means is, for instance, the point 2 comma 8 is on the graph. If you plug 2 into x cubed, you get 8. Well, for it to have symmetry with the origin, if you reflect it in the origin, you'll have a point down here, negative 2, negative 8. So if you have a point x comma y on this graph, you're also going to have a point negative x, negative y. So if you had the point, for instance, 327 on this graph, which you know it is, then you also know negative 3, negative 27 is on the graph. Okay, well that's nice, but visually that's really, really, really hard to tell. So the easiest way to tell symmetry with the origin is if you take part of the graph, if you were to reflect it in the y-axis, so you reflect that in the y-axis, and then you take that part of the graph and reflect it in the x-axis, you get the other part of the graph. And that's really what symmetry with the origin really means. It's really a reflection in the y and then the x. Or you could reflect it in the x and then the y. So odd functions have symmetry with the origin. All right. That then should get you through homework number 6. Now, Friday's homework was homework number 7. Now, I'm going to show you how to do that now, and then we won't be quite so far behind. So this is section 1.3, and this is really Friday's homework, homework number 7. And it's only like 8 problems, 7 or 8 problems. And it's on even and odd again, but this time you can't just look at the functions and tell whether they're even or odd or not. So that means we have to have a technical definition. And the technical definition of even and odd is simply this. F of negative x, if you do that and get the original function, it is even. But if you do f of negative x and get the opposite of the function, it is considered to be odd. All right, so what in the world does that mean? Well, let me show you on an easy problem first. Take f of x equals x squared. Now we know it's even because it's got an even exponent. But if you do f of negative x and substitute negative x into x in that equation, negative x times negative x is positive x squared. Well, you'll notice this is the same thing I started out with. So I end up with f of x. So since f of negative x ended up being the original function, that proves it is even. So that's how you prove something's even or odd. You have to do f of negative x. So let's take our most common odd function, x cubed. Well, if you do f of negative x, you substitute negative x into x. Well, if you cube negative 1 and you cube x, you get negative x cubed. Well, obviously that's not the original function, but it is negative 1 times the original function. Or in other words, negative f of x. So that proves it is odd. So that proves that the function is odd. So let's look at a couple of problems that are similar to what's on the homework. So let's take a look, for instance, at something that's like number 53. Let's say your function was square root x squared minus 9. And I want to know if it's even or odd. Well, to determine if it's even or odd, you do f of negative x. So you plug a negative x where the x is at. Okay, so what's negative x times negative x? That's simply x squared, and it didn't affect the 9 any at all. Well, since what you ended up with is exactly the original function, that means f of negative x is f of x. That means you got an even function. And what that means is you have symmetry with the y-axis. All right, let's try a couple more. Okay, here's a couple like 55 and 56. All right, say your function is s to the 5 halves power, should be x. All right, so from algebra 1 and algebra 2, the x to the 5 halves power really means square root of x to the 5th. So that's really what f of x means. Remember, the bottom number is your index, and then this top number, the numerator, is your exponent. Well, if you plug negative x into there, you get negative x to the 5th power. Well, remember, that just means you're going to do negative 1 to the 5th power and do x to the 5th power. And so you get square root of negative 1 x to the 5th. Well, you can't take the square root of negative 1. Well, if you can get a real number, you get I. So that's all you can do with it. Well, for this to be even, you would have had to have ended up getting square root of x to the 5th. Okay, well, you didn't. For it to be odd, the negative would have had to have been on the outside. Okay, you didn't get that. So this is neither. All right, you've got to get either the original function or negative 1 times the original function. And this negative 1, you can't take it outside any. All right, well, let's change the problem just a little bit. And that was to the 5 halves power. Let's do it to the 2/5 power. Let's make it a little bit different. So let's say g of x was x to the 2/5 power. Well, that means it is the 5th root of x squared. So if I do g of negative x, I put negative x where the x squared is, and negative x times negative x is x squared, or you can think of that as being you're squaring the negative 1 and you're squaring the x. If you square negative 1, you just get 1. Well, voila, we get the original function. So since g of negative x is equal to the original function, that means it's even. And so that means if you graph that, you get symmetry with the y-axis. All right, so that is how you do 53 through 56. Okay, let's do a couple of others. All right, these are like 69 through 72. All right, let's do absolute value of x plus 3. Well, if you plug negative x into the equation, you get this. All right, so how in the world do you handle absolute value problems if you didn't have a calculator? Well, the trick here is you could factor out a -1 out of what's inside right here. You know, factoring out -1 changes the sign of everything. And we have a rule about absolute values that say, well, I can do the absolute value of -1 and then do the absolute value of this. Well, absolute value of -1 is just +1, so you end up with this expression here. Clearly, that's not what you started out with. If you were going to have f of -x equaling f of x, you would have needed to end up with the exact original equation, and you don't. If it was odd, you would have had -1 times the function. In other words, -1 times the absolute value of x plus 3, and you don't get that either. So this is considered neither. And if you graphed it, it'd be pretty obvious because the graph, if you did this on your calculator and did absolute value of x plus 3, clearly that's not going to have any symmetry at all. I mean, it is symmetrical here, but we're only talking about symmetry with the x-axis, y-axis, and origin. Now, none of these will have symmetry with the x-axis. Like that has symmetry with the x. But notice that fails the vertical line test, and so it's not going to be a function. So that's why even in odd functions, we don't even mess with symmetry with the x-axis. All right, a couple of other oddball problems on the 69 through 72. This one's like 69. It's got something like the function is square root of 9 minus x. So you do f of -x, which means you substitute the -x where the x is, and you get minus a minus, which is a plus. All right, now if it were even, you would end up with the original function. Clearly you don't. If it was odd, you would end up with the opposite of the original function. In other words, -1 times 9 minus 6. Well, you don't have that either. I mean, if you wanted to factor -1 out, you would get something like -9 minus x. But you can't do anything with that -1 since it's a square root. Remember, square root of -1 is I. So this is a neither problem. And here again, the graph would make that obvious if you did that on your calculator. All right, so with that, we are now caught up. So you can now do homework 6 and 7 now. So on your homework sheets, here is basically what you need to do. So on your homework sheets, basically we did these two homeworks today. So that means we're going to do homework 8 on Tuesday, homework 9 on Wednesday, homework 10 on Thursday. That means our test will be Friday. And that's when homeworks 5 through 9 will be due. And then I'll get you an updated homework sheet for the rest of this later. All right, so you Probably don't have much time left in class right now, so if you want to work on homework, you can. I will put this lesson up on the internet later, or if you bring a jump drive tomorrow, I'll let you get a copy of it if you want to watch this again.